Hi everyone, welcome back to the modern portfolio theory and investment analysis. In the last chapter, we talked about single and multi-index models. And in this chapter, we are going to learn the methods for calculating the efficient frontier for the single index model. We have done the calculations for efficient frontier in chapter 4 as well, but that was when we have all the covariances. But in this chapter, we are going to focus on the single index model. The same thing like efficient frontier calculation, but only for the single index model. Let's start with a small recall. We are already familiar with how to calculate the return of the portfolio, which is the weighted sum of the individual returns. The weights are basically how much portion of that security we have in our portfolio. We also know how to calculate the variance of that portfolio, and that involves calculating the variance of this individual security as well as the covariance for each pair of security. These are the terms that basically annoy us, and that's why we move to the single index model, because there are just quadratically many. This all stuff are also kind of not new. We have already seen this before. This rho 1 2 is the correlation coefficient, which is the covariance divided by the standard deviation for those individual securities. Now let's take a look at the single index model that we have seen before. Here we basically assume that our return takes this form, which is part of it depends on the market and the other part depends on, well, not on the market, the independent of the market. This AI is then broken down into two parts, which is the expected value is alpha I, and this part, which is the noise part, which is EI. The expected value for this EI is 0, and the variance for this EI variable is denoted by this thing, right? So sigma square EI. And overall, the equation becomes something like this. We have also seen this curve in chapter 4 before. This is for when short sales are allowed and riskless borrowing and lending is also allowed. Okay. This curve basically goes all the way to infinity when the short sales are allowed. It will stop somewhere if the short sales are not allowed. And when the riskless borrowing and lending is allowed, we get this type of a line which touches this curve. And that line is our efficient frontier. So in chapter 4, how did we calculate our efficient frontier? We basically maximize the slope of this line, and that involved a lot of different steps, right? So we ended up solving a bunch of linear equations through Gaussian elimination. And when we talked about different scenarios when short sales were not allowed or riskless borrowing and lending were not allowed, and all those combinations that basically ended up involving a quadratic programming solver, right? So that process was fairly involved, and compared to that, when we are using single index model, this process is going to be a lot smoother and a lot simpler. Okay, so now let's talk about that process. So first we are going to order our securities or stocks by this particular ratio. So this is kind of a very well-known ratio, which is called excess return by risk ratio. So we know the return of these individual securities, and we know the risk-free return rate. So recall that we have riskless borrowing and lending allowed. So therefore we have a risk-free borrowing or lending rate. When we have this, we subtract this risk-free rate from RI, we get the excess return for this RI. That's what we calculate, and we divide it by this risk measure, which is beta I. So once we have ordered these stocks by this ratio, so this order is kind of meaningful. How is it meaningful? Is that if, let's say in our order, if we decide to include one of the security, let's say security I, then we know that everyone that is in that order above that security will also be included. Security I minus 1, I minus 2, all of them are also included in our optimal portfolio. And on the contrary, if something is not included, anything that has smaller ratio than that security will also not be included. That's why this order is somewhat meaningful. So I'm not going to do the derivation of this process or formula and why exactly it gives the optimal portfolio. But if you are interested, we can make a separate video about it. So let me know in the comments below. Anyways, so get back to the process. So once we have ordered the stocks by this ratio, what we are going to do is we are going to decide a cutoff value, right? So this is, let's say, called a C star value, cutoff value. And anything above this value, so all the securities that have this ratio bigger than C star will be in our optimal portfolio, and anything that has this ratios less than this C stars will not be in our portfolio. That's the second step. So now we know which securities will be in our portfolio. Now the final step will be to calculate what should be their proportions. And for that also we have a very simple formula which we are going to see in some time. Let's start with calculating the formula for C star. We are going to calculate a CI value for first I stocks which are ordered by this ratio. So the formula is something like this. So it kind of seems a bit involved, but when we go to the example, we'll see that it is not that hard to calculate. It involves a bunch of this type of summations, and all the things are kind of very easy to calculate. Sigma m is already given to us. The betas are also given to us. Sigma square Ej will also be known for us. Basically, all of these things are known and it's very easy to calculate. How are we going to select the C star is that we are going to calculate the Ci value for every I, which is like C1 represents C star value if we only include our very first stock, the one that is the highest excess return by risk ratio. C2 will be again like the C star for the portfolio, which consists of the first two stocks, which has the highest excess return by risk ratio, and so on and so forth. The C3 will be if we include the top 3 stocks, C4 will be top 4 stocks, and so on and so forth. We stop when one of the CI has value which is greater than this ratio. In our portfolio, we are going to include all the security which has the CI value less than this ratio. As soon as we hit one CI which is greater than this ratio, the one previous that, it will be our C star. So this is when the short sales are not allowed. If the short sales are allowed, we go all the way to the end, like we are going to include all the securities. That basically means that some of the securities will have the negative representation in our portfolio. Basically, that means that we are going to sell those securities instead of buy them. Once we know which stocks to keep in our portfolio, the last step is to calculate their proportions. And so this is how we are going to do it. So that's the last step. We are going to calculate the proportions by this particular formula, which is ZI, which is excess return to risk ratio minus this C star value. When the short sales are not allowed, this term in the brackets is always going to be positive, and therefore the entire ZI term will be positive. This ratio, again, like you have to just remember it or assume that it works. Again, like as I said, I'm not going to do the derivation in this video. If you are interested, we can always create a new video to cover why this formula gives us the optimal portfolio and their proportions. That's the formula for ZI, and unfortunately these proportions do not sum up to 1, so we have to normalize them. This is how we normalize them. We calculate this Xi's, which basically will sum up to 1, which is simply just ZI divided by sum of all ZI's. That's again like we'll see in our example. Let's actually go to our example now. This is our example. We have a sigma square m, which is given to us, which is 10. We also have 6 securities. We have their expected returns, RIs, their betas. Betas are there. These are basically like some sort of risk measure. And we also know their sigma square EI. So these are also, all of this part is given to us. And we are also given this risk-free return rate, which is 5 for our example. The first step is very simple. We are going to calculate the ratio, which is Ri minus Rf by beta. So we have this Ri, we have this Rf. So we are going to subtract 5 from these numbers and divide them by this beta numbers. Once we do that, we are going to sort them. So this is what I have done till here. So I calculated this Ri minus Rf, which is something like this, and divided by that by beta. And then I ordered these securities in the decreasing order of this ratio, which is what we are supposed to do in our first step. The security 1 is at the top, security 6 is second, 2, 5, 4, 3, we have that order now after that. Now the second step is to calculate this formula. So this formula kind of seems intimidating, but it's not that hard to calculate. So we are going to calculate this formula in parts. So this term calculates beta square by sigma square EI, so which is this one, right? So beta square by sigma square EI. I calculated that part. So we already have beta and we already have sigma square EI. So I square this and divide it by this. So I get beta square by sigma square EI like here. So we calculate it for all of them. The Excel is kind of, we just have to type the formula once and then we just simply drag them. It's kind of very easy to calculate. So this is in the summation, right? Here the summation goes from 1 to I, security I. This is the cumulative summation. The first term is just as it is. The second term here is the sum of these two. This term here is the sum of these 3, and so on and so forth. This is again like very easy to calculate. You just have this sum formula. In the first part, you just keep it constant. The second part is like the variable, and you just simply drag it after, here. You just simply drag it after that and it calculates it for all the remaining cells as well. This part is the cumulative summation of denominator, which is this column. Now we are going to calculate this term, which is Rj minus Rf times beta j divided by sigma square Ej. This is also a bit involved formula, but it's kind of very easy to calculate. Notice that we have already calculated Ri minus Rf by beta in this column. And here we have beta and the numerator and sigma square in the denominator. Here beta is in the denominator and here the power is -1, here the power is 2, we need 1. So if we just simply multiply these two columns, then we get this term. That's what I have done in this column. Basically just multiplication of these two columns. These two columns. And that I have done it for all the securities. And this after that is the cumulative summation in the numerator, which is this entire summation part. So first term is as it is, second term is sum of these two, third term is sum of these three, and so on and so forth. After that, calculating CI is very simple. We just multiply this cum sum by sigma square m. We multiply this cumulative sum by sigma square m, add 1 to it, and then divide that entire thing with the first thing. That's the simple formula that I have typed for first one, and just simply drag it through, and that's how we calculate the CI values for all the securities. Now we have to select the C star value, and for C star, the goal is that this Ri minus Rf by beta should be greater than Ci. For first two of them, that is true, but for the third security, this ratio is smaller than this Ci, so therefore our C star is this one. That basically means that in our portfolio, we are going to include the security number 1 and security number 6, these two securities. And for that, we have to calculate these ZI values. ZI values, again, like we can calculate it, it's very easy. We just have to go through this formula, which is Ri minus Rf by beta I minus C star. So that's basically this ratio, and we have to subtract this C star value from this ratio for all of these ratios, and then multiply that by beta I by sigma square Ei. Beta is here and divided by sigma square Ei, which is divided by this one. That's how we calculate the ZI value. We only need to calculate it for the first two, but I have calculated them for all of them just to demonstrate that it will be negative because this ratio is smaller than C star for the other securities. And since we are in this scenario where no short sales are allowed, we are only going to deal with these first two ZI and we are going to ignore all of that. Calculation of this XI is just simply ZI divided by sum of these two, which is 0.475, which basically means that 47.5% of our portfolio consists of the first security and 52.5% of our portfolio consists of the second security, which is, the security number 6, which is this one. Okay, so now we are going to talk about what happens when short sales are allowed. So in that case, we are not going to stop our calculations for CI. We'll go all the way to the end and we'll include all the securities, and C star will be the one that includes all the securities. Here in this example, we stopped here. Like C star is the one that has only two, that is basically the CI for the first two securities. But when short sales are allowed, this will be our C star, which basically includes all the 6 securities. This one will be our C star. Once we have the C star, the rest of the steps are kind of similar. We have to calculate this ZI in the same way, XI is also in the same way. And we know that when we calculate XIs this way, the sum of XIs will be equal to 1. This is when short sales are allowed. Sum of XIs will by default be equal to 1. But if we do it this way, then the problem is that this number XIs will be crazy. Some of them will be way bigger than 1 and some of them will be way smaller than -1. So that would basically means that by, let's say, 200% of put 200% of our budget in buying one security, and to cover the excess amount, we have to sell one of the security by more than, let's say, 600% or 200, 300% or something like that, right? So those are like kind of crazy numbers that we get. And in order to avoid that, we want to have this property, which is sum of mod of xi should be equal to 1. And in order to get that, what we do is we make a small change in how we calculate xi, which is instead of dividing it by sum of zi, we divide it by sum of the absolute values of zi. That's the only change. So now if we go back to our example, so when short sales are allowed, we have to calculate our zi, and for calculating the zi, the formula is still the same, except that C star value is not this one, but this one. The C star value that involves all the 6 securities. Same formula, we calculate the ZI values. This time again, like we are getting negative values, but that is okay because short cells are allowed. We calculate the absolute values for ZIs. The Xi's are, as I said, it's basically involves Zi divided by the sum of absolute values of Zi's. So that's our Xi's. So this is basically like the final thing that we need. But if we want to calculate the absolute values of Xi and then sum them up, you notice that all these values basically sum up to the value 1. Okay, so this was the case where short sales were allowed and riskless borrowing and lending was allowed. So what happens when riskless borrowing and lending is not allowed? This line will basically go away. That's the case. Like, so when riskless borrowing and lending is not allowed, this line is no longer present. This is our efficient frontier now. And how do we calculate that? We need to calculate any 2 point of this efficient frontier like we did in chapter 4. And the process is also kind of the same that we followed in chapter 4, which is basically we assume two different risk-free return rates and calculate the tangent line value for this curve. Right? So 1 point will get here, the other risk-free return rate will give us some another point, and any combination of those 2 points in our portfolio will give us some other points in our efficient frontier curve. So far everything is simple, but when short sales are not allowed and riskless borrowing and lending is also not allowed, that's when things get a bit complicated. And in the book, they haven't given much details about how to calculate things except for this brute force solution, which is this solve this entire portfolio composition problem for a large number of values of RF, like we did for the 2 values in the previous case. We have to do it for multiple values in RF, and then that will basically give us the approximation of this complete efficient frontier. I can't cover anything more than that in this video because no more details are given in the book, so we'll leave it at that. Another interesting part that we are going to deal with is constant correlation model. Okay, we learned how to calculate this efficient frontier for the single index model, but we also learned that this constant correlation model, where we assume that these covariances between securities are constant, that is kind of also very, very interesting. That also resulted in very highly accurate predictions. We are also going to learn how to calculate the efficient frontier for this particular model. So the process is again very, very similar to the single index model with slight differences, right? First step is again like the order of the stocks by this ratio, which is access return to risk, but the risk part is kind of changed. So previously we had beta, and in the constant correlation we don't have beta, so we have the standard deviation, which is sigma. So once we have ordered our stocks in decreasing order of these ratios, the second step is same as the previous step, which is find a cutoff value C star, and then whatever makes that cutoff will be in our portfolio. Everything else will be discarded. And finally, calculate their proportion. So this is when short sales are not allowed. When short sales are allowed, every security will make it into the portfolio, and some of them will be short sold. Only thing that are different is the formula for C star and the ZI equation, calculating their proportion part. The changed parts are the CI equation is something like this. We have this rho, we have the constant correlation model. So this rho part, the correlation coefficient is constant, and that's why we have that in our formula. This part is kind of very easy to calculate. It's just excess return to risk ratios, and their sum is there, and that entire summation is multiplied by this part. So that's how we calculate CI. Again, like the same thing, when this CI is more than our this particular ratio, that's when we stop. The one previous to that will be our C star. And finally, once we have calculated all the C star and which securities should make into our portfolio, this is how we calculate the ZI. It's again like this part is kind of same as the previous single index model. And the only thing that has changed is this factor part, which is 1 divided by 1 minus rho times sigma. After once we have calculated ZI, the process for calculating XI is kind of same as the single index model. Let's talk about that in another example. That's the second example that we are going to use that. So this time we have 7 securities, and we have our expected return, which is RI, that is given to us. Standard deviations are also given to us. And also we have this risk-free return rate and this rho, which is given to us, which is 0.5. So the first step is basically calculate this ratio, Ri minus Rf by sigma j. So that's what I have done, Ri minus Rf by sigma. Sigma is basically this, right? So we just simply calculate this ratio, and once I have calculated these ratios, we just order them in the decreasing order. That's how we have ordered them. These are the securities. First two are again like as it is. The last five, they basically got reordered 5, 6, 4, 3, 7. I am going to use I as the index for this, which is 1, 2, 3, 4, 5, 6, 7. I is not this index, but this index. This is not I, this is I. So keep that in mind when we use this I in this formula over here. After that, the process is very simple. We have to calculate this cumulative summation j equal to 1 to I. Like we did for the previous cases, it's very simple. The first term is as it is, second term is the sum of these two, third term is sum of these three, and so on and so forth. Just calculate this cumulative summation, multiply them by this particular factor, which is this factor is rho divided by 1 minus rho plus I rho. So that's what I have done in this formula. That's the formula, which is rho by 1 minus rho plus I rho. And then finally we calculate the Ci, which is multiplication of these two. Once we have calculated the Ci, the rest of the process is again similar. This is the last place where this ratio is bigger than Ci. After that, this ratio gets smaller than Ci. This is our C star. This is the formula for calculating Zi, which is this ratio minus C star, and multiply all of that by this factor. That's what I have done for all of them. We actually need to do it only for this 4 only, but I have demonstrated this process for all of that as well, right? So the remaining ones as well. The process for calculating Xi is divide this Zi by sum of this 4, and that's our Xi's. This is our final portfolio. So this 4 securities, security number 1, 2, and 5 and 6. This is 1, 2, 5, and 6 basically makes our portfolio. 23%, 23.7% in the first one, 15.8% in the second one, 47.4% in security number 5, and 12.9% in security number 6. So when short cells are allowed, the process is again like the same as the one that we have seen in the single index model, which is this becomes our C star. Using that, we calculate the Zi, we calculate the absolute values of Zi, then we calculate the Xi's, which is Zi divided by sum of all of this. This is our final portfolio, and you can notice that some of them are negative. That basically means that we have to short sell these 3 securities, 4, 3, and 7. And if we just sum the absolute values of Xi, then again they will sum up to 1. That's the entire process. In this video, we have seen all of these things, which is for single index models, we have seen how to calculate the efficient frontier for all these 4 cases where short cells are not allowed or allowed, and whether the risk-free lending and borrowings are allowed or not allowed. This last one particularly was tricky. The only way I showed to calculate the efficient frontier for the last one is the brute force method, because like nothing better is given in the book. And we also saw how to calculate the efficient frontier for the constant correlation model. And that brings us to the end of this video. Hope you have learned something new. Please hit the like button and subscribe to the channel for upcoming videos in which I'll cover the next chapters. Thank you. Bye.